Hello everyone, I'm John Kildevarma and I'm going to talk about techniques of splicing losses. So let's first know what is fiber optics splicings. Splicers or splicers are connections between two fibers. Splicing involves cutting off the edges of the fibers to be spliced. While connectors are demountable and splicers are permanent connections. Connectors and splicers may have different use, but the basic specification of splicers are the same as that of connectors. Splicers are also permanent termination for some specifications for splicers are loss, repeatability, environment, reliability, and back reflection. They are also easy of termination and cost effective. Some types of splices are there are two types of splices: fusion splices and mechanical splices. Let's talk about now fusion splices. Fusion splices is done by welding two fibers together, usually with an electrical arc, with an automated splicer which align the fibers exactly. It has the advantage of low loss, high strength, low back reflection, and long-term reliability. They normally uses active alignment to minimize splice loss. Fusion splicers are also very expensive, but they are fully automated machines. They also do all the works. Fusion splicers are expensive, but the splicers are cheap. This is the each splicers which they make with the machine are cheap. So if we are doing a lot of splicers, then fusion splices is more cost effective. Uh, so now let's talk about mechanical splices. Mechanical splices uses an alignment fixture to mate the fibers and either a matching gel or an epoxy to minimize back reflection. Some mechanical splices use bare fibers in an alignment bushing, while other closely resembles connector farewell without all the mounting hardware. Mechanical splices also relies on tight dimensional tolerance in the fiber to minimize the losses. Mechanical splices like the Ultra splice use some mechanical alignment features, example a glass capillary, and some means of securing the fiber in the splice. Mechanical splices are more common in multi-mode fibers. So now let's see how what are the losses that can cause due to splicing and how can we reduce them. So splice loss is minimized when the two fiber cores are identically and perfectly aligned. The connectors or splices are properly finished and no dirt is present. The end gap causes two problems: is insertion loss and return loss. The emerging cone of light from the connector will spill over the core of the receiving fiber and be lost. The air gap between the fibers causes a reflection when the light encounters the change in refractive index from the glass gap to the air in the gap. The end finish of the fiber must be properly polished to minimize loss. A rough surface will scatter light and dirt can also scatter and absorb light. Two sources of loss are directional mismatch in numerical aperture and core diameter. Differences in these two will create connections that have different loss depending on the direction of light propagation. And since And since the optical fibers is so small, typical airborne dirt can be a major source of loss. When the conductors are not terminated, they should be covered to protect the end of the fuel for from dirt. Now, light from a fiber with a larger numerical aperture will be more sensitive to angularity and gap. So, transmission from a fiber of larger numerical aperture to one of a smaller numerical aperture will be higher loss than the reverse. Light from a larger fiber will have high loss coupled to a fiber of smaller diameter, while one can couple a small diameter fiber to a large diameter fiber with minimal loss, since it is much less sensitive to end gap or lateral offset.